Hello friends, this is a simply supported beam carrying a part UDL of 2 kN per meter in the span of 3 meters. The overall length of the beam is 5 meters. So in this diagram we can calculate the shear force diagram and bending moment diagram. So we need to find the reactions at the first time and the next shear force values and next bending moment values to draw the SFD and BMD. At firstly, reactions. I am taking the moments about A, so we can take reaction at B into 5 is equals to downward UDL load 2 into 3 into UDL is the exactly act on the middle point, so 3 by 2. So this was cancelled. This is 9 by 5. So RB is equals to 9 by 5 value. So this was 1.8 kilonewtons RP. So here total load how we can calculate UDL load into distance of the UDL occurs. So 2 into 3, 6 kilonewtons is the total load. So RA value is total load minus 1.8 RB. So we get 4.2 kilonewtons of load at the RA. These are the reactions. So now shear force. In the shear force, reaction at A is also equals to the shear force at A. So shear force at A is equals to 4.2 kilonewtons. Shear force at C. At C point. At this point we can calculate all the reactions to this. So all the forces acting on the point C. So what are the forces at the left side? An upward force and a downward UDL. So upward force RA 4.2 minus downward UDL load 2 into 3. This was minus 1.8. So from C to B there is no load. So shear force at B, it was extended up to same intensity of load. So minus 1.8 kilonewtons is the shear force at B. So now we can draw the shear force diagram for the required beam. So this was a baseline for the shear force diagram. So shear force at A, how much? 4.2 kilonewtons. So it extends up to some intensity, 4.2 kilonewtons. So from here to point C, this is C, B, and this was A. So shear force at C will minus 1.8. Minus value means it will lies below the datum line. So maybe this was a 1.8 kilonewtons. Shear force at B also minus 1.8, so same height, 1.8 kilonewtons. So how we can join? We can remember that in the shear force diagram, wherever the UDL force is acting, the diagram will be triangular. So it can act like this, and it was straight up to here, and it joins to the 0. So this was the positive shear force, and this was the negative shear force, SFD. So we can calculate this distance. At the shear force is 0, where there will be the maximum bending moment. So we need to find the distance from the support to this point. So it is treated as x. From here to here span is how much? 3 meters. So this was x, means this was 3 minus x. So x distance. How we can calculate? X by 4.2. X by 4.2 is equals to distance by the height of the ordinate, 3 minus 6 by 1.8. 3 minus 6 by 1.8. Hence x equals to. So x equals to 2.1 meters. From where? From support A. From support A. Why we can calculate this x distance means, in the calculation of the bending moments we can calculate at the 2.1 meter span also. So now bending moments, according to the shear force, according to the simply supported beam, maximum bending moment at A and B will be 0. At supports will be 0, end supports. So we need to find only at the x distance what is the bending moment, and at the point C what is the bending moment. Mx and Mc we need to calculate. For the simply supported beam, at the end supports So mx means m 2.1 meters of span. So how we can calculate the 2.1 meter point? We need to find all the reactions to this point. So what are the loads we have? An area load and the UDL load. So we can take the clockwise movement first. 4.2 into 2.1 meters of span, and next anti-clockwise movement of UDL. 2 into 2.1 into UDL acts at the middle point, 2.1 by 2. So I can written like this: 4.2 into 2.1 minus UDL load, 2 into 2.1 into half of the distance, 2.1 by 2. So I got the value of 4.41 kilonewton meters. So MC, where the point C is located at the distance of 3 from A. So 4.2 RA into 3 meters of span minus entire UDL at between the A and C span only, not entire. So 2 into 3 into 3 by 2. So MC is 3.6 kilonewton meter. So now we are calculated all the bending moments. So now we draw the bending moment diagram for the required section. So this was a diagram. This is the baseline for our bending moment diagram. So at x distance 2.1 meters, what is the moment? 4.41 kilonewton meter. So at here this was, I am putting it as 4.41 kilonewton meter. And next at the point C, 3.6 means it is lower than the 4.41, 3.6 kilonewton meter. So bending moment diagram for the simply supported carrying UDL, that is a parabolic shape. So it is draw like this, and from C to B there is no load, so it is a linear. Bending moment is positive for the simply supported beams, so positive. This was the problem. I hope you understand, friends. Thank you.